Ready to move forward? That's it. It's not very difficult at all. Okay, this is the microevolutionary process, and it itself is quite simple too. 5 basic steps. That's it. So, variation acted upon by natural selection leads to genetic divergence, supported by reproductive isolation, can potentially lead to speciation. That's it. I want you to remember that mantra. And if you remember that mantra, you'll remember the entire microevolutionary process. I'm going to repeat it. Variation acted upon by natural selection leads to genetic divergence, supported by reproductive isolation, potentially generating speciation. Doesn't have to, but can. All right? That's it. So we're going to walk through each of these different steps in the microevolutionary process to understand them conceptually. So here's the first thing that's really important. You as an individual do not evolve. Once you're born, you're done. Okay? That's it. You're not going to change. That's who you are. So populations do not evolve. Excuse me. Individuals do not evolve. Populations do. All right? The population evolves, not the individual. Populations, like these penguins here, have variation in the traits among individuals. Look around the room again. Massive amount of traits. So microevolution then is the change in allele frequencies in a population generation to generation to generation. That's microevolution, change in allele frequencies. There's different ways to think about this. Now, I'm an ecologist, so I think about things from the top down, not the other way. So I teach this from the organism perspective. I think the organism itself is quite important. Some population geneticists don't really view that as much. They look at you as a vessel just to carry the alleles. The alleles are the only thing that's important. You're kind of irrelevant, right? But to me, that's not the case. I think the organism and the alleles they carry are a unit that you can't quite separate, right? So let's go forward. Let's talk about, again, the features that characterize a population. I've already alluded to them. So in this case, we're talking about morphology, the form of something, how you look. We're talking about physiology. That's how you function. And then we're talking about ecological traits. That's behavior or the way you act. Okay? So yeah, morphology, physiology, ecology. In reproducing species, there's variation in all those different kinds of traits across the board. So individuals are going to vary in all 3 of those types of traits. Now these traits can occur as discrete characters. Basically that means you're either this or you're that. So for instance, these ladybird beetles are a nice example of that. Some have no spots, some have 2 spots, some have 5 spots. So it's basically distinct forms, right? Not some blend, but it's this or it's that. That would be discrete. Or the features can be quantitative in the sense that they vary along a continuum. They're a blend, okay? They are a blend. So discrete, this or that, or a blend. Those are the ways that the traits typically fall. So variation then, traits can be positive for your survival and reproduction. They can be negative for your survival and reproduction, or they can be completely neutral and convey no survivability or reproductive advantage. So that's what traits can do. So an adaptation, in a textbook version of adaptation, you're looking at an adjustment or a change to meet an environmental condition. What's the adjustment or change in? What are the 3 things again? Morphology, physiology, or ethology, your behavior, right? So that's the adaptation. There's an easy way to think about it. So again, another thing not in the textbooks, but makes a lot of sense intuitively to me. An adaptation is a functional solution to an environmental problem. That's it. It is a solution to an environmental problem. You solve it in 3 ways. Morphology, physiology, or ethology. Done. That's it. Okay? So it is a solution to an environmental problem. So an adaptive trait conveys an advantage in survivability and reproductive success. So an example would be, if you take a look at all these snails right here. They have all of this variation in their shell type. Just like you have variation in your hair colors, right? Your eye colors. Well, there's a selective advantage to those kinds of traits, depending on the habitat you're in. If I'm in, so here's a nice example over here. These are slugs. They're a little hard to see in the light. Let me turn it off real quick. All right, that was a little too low, right? Let's try that there. Okay, so It's hard to see, but these are slugs. They're exactly the same species. But just like we have differences in our pigmentation in our skin, so do they. But theirs is a little more extreme. So the one on the bottom is this nice kind of dark brown. The one on the top is kind of lime green. Well, why would you have that? Why would you have the dimorphic forms? They blend in different places. When the forest is dry, during the dry season, who does better? The brown one. But when the conditions are nice and wet, it's all greened out, who does better? The top one. So you're getting distinctive advantages by having those different morphs, okay? They're specialized for different environments. So that would be an adaptive trait. Maladaptive traits basically are negative. So they convey a decrease in survivability and reproductive success. And so all species have a tendency to have a certain amount of maladaptive traits. For instance, this birth defect right here. So this is actually not a common birth defect, but it occurs definitely in the human population at a definite rate. So most of you, if you had this, would you ever know? In the same way they lopped off your wagging tail, what would happen at birth? Most of the time they just lop it off because it's non-functional, right? Usually it just sticks out the end. How many of you have ever cracked their pinky toe walking around? Has anyone not cracked their pinky toe walking around? That's not a pleasant experience, right? You catch it on the door rail, on a chair, whatever. Think if you had that hanging off of you. Now here's the thing, so there's got maladaptive functionality, but all organisms have the tendency to have this basic trait. They like difference to a certain degree, but once you're too different, what happens? You're ostracized from all the communities, okay? All animals typically share that. Difference to a certain amount is actually a preferred thing. And we're going to see why that is. But too different, you're instantly excluded from the overall social unit. Something like that is quite different and abnormal. And so what happens is the tendency is to shy away from something like that, right? It becomes a maladaptive trait. And there's even better examples for these that we'll talk about shortly. So again, it decreases your survivability and your reproduction. Here would be an example. If you have spina bifida, your spine is located on the outside of your body and has it closed, is that going to be successful in your survival? No. Are you going to be able to reproduce in that 50 days? No, you're going to die. And so in that case, it's completely a maladaptive trait that's been expressed. All right. The last one is a very common one, and that's a neutral trait. Neither plus nor minus in terms of increasing your survivability or reproductive success. And we see a slew of these. How many of you guys have freckles? Yeah, probably about 99% of you do. You just don't realize it, right? So freckles are something that human beings carry. There's this little asymmetry and pigmentation in the skin. Does it got basically something about how would it happen to be maladaptive for you? If it made you die, but most freckles are not going to make you die. They might become malignant over time if they would change somehow from sun exposure or really chemical change them or modify them. But that's a rarity, right? Or it would have to decrease your reproductive success. So basically, we have to say, your freckle, I refuse to mate. And that doesn't happen either. So again, this is a completely neutral trait. It has no advantage or disadvantage in terms of survivability or reproductive success. Almost every single trait in a species displays some type of variation or variability. So let's talk real quickly about some features in human beings here for a few minutes that would basically mimic these. So tell me some adaptive traits for human beings that increase our survivability or reproductive success.
Our brains?
We have large brains per body size, one of the biggest. Okay, there's other organisms that are right up there, like dolphins, some of the cetaceans and things like that. But we have a very large brain capacity. Certain areas of our brain are enlarged. They give us all kinds of ability to solve problems, predict into the future, be proactive, all kinds of great features. There's still some real primitive aspects of our brain as well. If it ain't broke, don't fix it. Could probably use some fixing. But it gives us a massive advantage. That ability to problem solve has made it so that we could conquer the entire planet, right? And basically subjugate every other living thing on the planet pretty much. That's a massive advantage. What else?
Thumbs.
Thumbs. Opposable thumb. The simple opposable thumb. Now here's the advantage of this. So obviously the thumb gives us a couple different things that it does very well. So there are two primary grips that an opposable thumb allows. Now we have the most opposable thumb of any of the organisms on the planet, including the other primates, right? Primate thumbs are located further down. They look like this. And the thing is, we can go across all the fingers, right? So you can kind of do that exercise. If you play musical instruments, you kind of warm up your fingers and things like that. For me, that's nothing. I can just move right through it, right? Do anything twice about it. If you ask a chimpanzee to do that, they can do it, but they have to think about it. They do it slower, and they can't reach. That's the problem. They can bend, but they can't connect all the way. It takes them a lot of effort to do so, because the thumb is located further down on the hand, and it's shorter. So this nice long thumb that we have, completely opposable, allows two different grips. This is the first grip that you're doing right now. This is called the precision grip. What does it allow? Writing, the fine use of tools, fine tool manipulation. Here's an advantage that you have as well. Your thumb, your prints on your fingers, have more nerve endings exposed per surface area than other animals. So incredibly fine ability to detect sensation, pressure on the tips. What have you given up for that? We don't have claws anymore. So if you tried to claw someone, is it very effective? It's so weak they spring right off. Think about a lion clawing into you, what that would feel like. If you tried to claw the lion back, is it working well? So you give up something to get something. So this precision grip allows the fine manipulation of tools. And then there's another grip that has given us a massive advantage on the planet. It's this grip. What's that? That's called the power grip. And what's it used for?
Grab stuff.
Beating you over the head with something. Okay? And so this is the aggressive or defensive grip for using tools in an offensive or defensive manner. So between this and that has allowed us the manipulation of tools and a variety of other things, weapons, you name it, to be a formidable animal. Without these things, we're worthless. We can think, but are we good runners? Nope. Everything runs us down. Do we have a ton of endurance? On some things we do, but can we run forever? No. Tire out quickly. Are we good swimmers? No. Do we have great eyesight? No. Do we have a great sense of smell? No, we kind of don't. And so there's certain things that have given an advantage. It's this combined with this. Because here's the thing. If I had a horse that had a cognitive brain like ours, they could think all the same things we do, but they'd be like, you know, I wish I could invent this particular machine to do this and this, but I just can't do that. Pick it up, I can't do a whole lot with it. So it's the combination of the ability to think about it and then actually execute it. That's the two big advantages we have. So that's a great adaptive trait. What else? What we're doing right now. So we have an amazing variety of vocalization. So do many other kinds of animals. But of the primate group, ours is by far the most advanced. So I can convey tremendous amounts of information vocally in a very small period of time. Other primates and other organisms might not have that same ability, though some do in different ways to convey a great deal of information. An example of that would be squid. Squid convey a tremendous amount of information, not vocally, but how? With colors. So they can basically, when I transmit vocally, it's a cone of vocalization that I project forward. People behind me can't hear me very well. It only can extend so far, etc. It's kind of like a cone of influence. A squid can transmit communication in all directions, three-dimensionally around it, just by changing its color, flashing different signal pattern formation. An amazing amount of information can be delivered almost immediately to other members of the group. So vocalizations are great. Can chimpanzees vocalize? Talk like we can? Can they say some words? Absolutely. You can teach them words, but they don't have the vocal apparatus necessary to have complex language like we do. So they can, when you were a little kid, did your parents ever read you like Pop on Pop? Like that Dr. Seuss book? You ever seen that thing? It's like cup, pop, up. You ever seen that? They can learn that. So you can teach a chimpanzee simple words like cup and pup and up, and they can do it. But anything beyond that's really tough. Now here's the thing, however. Just because they can't say it, does that mean they can't understand it? No, they can understand vocal language, and ours, fine. They can also have their own language. And so basically, has anyone ever seen Coco the gorilla? She's an amazing animal, right? She's probably smarter than I am. And so she has an amazing, intricate language, and she does it via sign. And so they're completely adept at speaking. They just don't have the vocalization to do it. But they know exactly what's being said. She's an amazing animal. She creates her own sentence structure completely independently. Very intellectual animal. Pretty amazing. So that's another adaptive trait, the ability to convey information rapidly via vocalization. What else? I'm doing it right now. What is it? I'm standing on two legs. Is that unique to human beings? No, that's been a great adaptive trait for many things. Think about the dinosaurs. Plenty of them walked on two legs, right? Ostriches do it today. Emus do it today. They're all walking on two legs. What advantage does it give? Especially for us, it gives us a big advantage. What's that? Well, it definitely gets you off the ground. And in some cases, like for something that's even by a tetrapod like a camel, that's really good. But there's something more important about this. What does it free up? It frees up the hands. Instead of walking around on four, walking around on fours, I'm a lot faster. But when I go up like this, I'm slower, but what do I instantly get? I have the ability to utilize my arms for other things. Tool formation, but one thing very important, gives us a big advantage. Think about our early evolution, which was the grassland habitat. So the ability basically to get from forest to forest is quite important because the grasslands are a dangerous place. Why? Because they're full of predators. All right? And they would like to eat us. And so here's the thing. When you got to run from forest group to forest group, you better move quick. And who slows you down? Babies slow you down. So if they have to be on all fours, and you're on all fours, the problem is you got to go at their pace or you have to leave them behind. But if I have a hand here, what can I do?
Pick it up.
Pick them and run. So that's a massive advantage. So it's the ability, again, to basically locomote. Also to look over the top of the grass is really important. When you see organisms hunting in grasslands, you ever seen I think we talked about this, you ever seen the little white tufts on the end of like lion tails and stuff like that? Well, lions don't want to vocalize because if I vocalize, what will that do if I'm the human, primitive human out there? I'll know where you're at and I'll go the other direction. So what they do is they flick their tail like a little periscope up like that, and they can see the flicking of the tail. That's how they communicate as a hunting pack. But if I'm up like that and I see a tail, what do? I'm the other way, right? So it gives a massive advantage. So bipedalism is great. It also causes us to screw up a lot because that's why human beings have bad backs. Like most of you guys, I have a really bad back from, some competitive sports stuff, and, I'm kind of a mess. And so this kind of bipedal locomotion puts a tremendous amount of stress on the pelvic curve. Can gorillas walk on two legs like we do?
Yeah.
They can, but for little short periods of time. So they're not designed in the same way. So they have their quadrupeds, they kind of go like this, and they're knuckle shufflers, right? So they shuffle on their forward leg. The reason being it has a lot to do with their skull formation. So when you look at our skull, it's very flat in front. So the thing is, to generate this had to be modified. Because what's happening is gravity is coming through us in a straight line. But when I look at a gorilla, what happens is their jaw protrudes forward, their skull protrudes back. And that balances because the vector is going down diagonally, not straight down. So if I had a skull like a gorilla, and I was bipedal, every time I took a step forward, what would happen to me? That skull would wing me back and forward like that, and it'd screw up my locomotion. It'd be energetically ineffective, and my balance would be all screwed up. So here's the thing. This developed first in terms of evolutionary time. This has caused the skull, basically the jaw to go in, the forehead to come out. Interestingly enough, that leads to another problem in our jaw, which is what? Not enough space and too many teeth, right? Which is a secondary problem. So bipedalism is a really great feature. You want to see some cool video? There's this one gorilla who's taken to walking upright because he was born in a zoo and he saw all the people come walking by every day to look at him. And so he decided, well, that must be the way to walk. So he cruises around on 2 feet all the time. And it's a really it's kind of funny because it's all it's actually kind of fun to watch, it's really strange. But they can do it, So they can, it's just not very effective for long periods of time. They can. All right, so there's lots of adaptive traits. There's another really great one that we bear. What else? It has to do with our eyes. They're right in front of our face. And so typically predatory animals' eyes are to the front and prey eyes are to the side. And ours are very much forward facing. It gives you an advantage. When the eyes are in the front, what increases? The area of overlap of vision. And wherever vision overlaps, what do you get in that area of overlap? You get depth perception. That's exactly right. We have it because we come from a shared ancestry of organisms that swung in the trees, monkeys, right? Things like that. And so basically, if you go back in time, there's all these precursors. Well, if I'm a arboreal primate, I better be able to judge the distance accurately between tree 1 and tree 2. Because if I make a mathematical mistake, what happens to me? I fall to the ground and I'm dead. So this is really an important feature. But we're kind of weak in it. So like if I was to stick an eagle up here where their eyes are dead center in the front of their head, their vision and their area of overlap is so intense that an eagle up here could see the pores of the paint in the wall. That's how good their vision is, right? And also they'd be able to judge that depth with almost, judge that distance with almost perfect precision. Right? If I tried to judge, I'd slam into a wall or something, right? But they're much better than we. So all these things are adaptive traits that human beings have. Talk about a maladaptive trait for human beings. What's a maladaptive trait? Well, any kind of birth defect that's expressed that's going to affect your survivability or your reproductive success if you're born without gonad, I mean, things like that, right? Those are all things that can happen. Those are all maladaptive. Give me some ones that are more, might be a little more common that you might not think about.
Appendix?
The appendix is always one that's thrown out there. Interestingly enough, the appendix is not a maladaptive trait at all. So in early development, the appendix is quite active in regulating digestive process in the body. And then it fades into kind of more dormancy. But what we're starting to realize is there are many research exercises that are saying it now is a repository for beneficial bacteria in the gut. So once you, like say you nuke your gut with antibiotics, because of the nature of the appendix and the way it's kind of closed off, antibiotics are having a hard time getting in there. And so what often happens is that is the reservoir from which you recolonize the gut with beneficial bacteria. So it appears it might even have benefit in the long term. The only time it's a problem for you is if it gets infected and you have to get removed or it gets ruptured or something like that. But it is not a maladaptive trait. What else?
The epiglottis?
The epiglottis is actually quite adaptive because what it's doing is it's closing off one when you're drinking and opening up another when you're breathing. If you didn't have it, you basically drown every time you take a drink. What else? I just mentioned it. No, kidneys are highly adaptive. No kidneys, bye-bye. They'll last a day.
Wisdom teeth again?
Wisdom teeth. Completely maladaptive. Right? I told you that bipedalism evolved before the change in the jaw. The jaw had to catch up. The problem is you got an extra tooth that doesn't fit. You used to have a big jaw for grinding plant material. Now it's designed to be plant and animal material. It's much smaller. But you still have that tooth. How many people had their wisdom teeth out? Raise their hands. How many people did not? All right, so you can see there's a difference here. Now here's the thing. In the past, if you had a small jaw but too many teeth, and you didn't get that wisdom tooth out, what happens to you? It becomes impacted, and then what? It becomes infected, and then you die from blood poisoning. And there used to be a time that wisdom teeth killed many, many people. And you could actually look at skulls to see that it was a maladaptive trait that was actually being weeded out of the population. Because people with the wisdom tooth were dying. Is that the case today? No. You have wisdom teeth and it doesn't fit your jaw, you just want to screw up your teeth. Most people just do it for aesthetic things now, right? You get it removed. You pop it out. Doesn't kill you. But if left to its own devices without modern medicine, it could kill you. Maladaptive, right? I never had mine out. The reason why is because I saw my friend get it when we were in high school, and he had this gigantic fat face, and it swelled up, and there was like blood and stuff everywhere, and I was like, hell no, I'm not doing that. And I just got lucky enough because I got a big jaw, so I didn't have to get that. Didn't really mess anything with it. All right, so those are maladaptive traits. Neutral traits, slews of them, convey no advantage or disadvantage. Give me some of them. What's that? No, eyebrows are actually adaptive. What does an eyebrow do? It stops dirt and jump from getting into your eyes and from washing down into your eyeballs. That's exactly it. They're like windshield wipers. They don't move. They're protective. What else? You talk about the tailbone. No, it's just basically inert, doesn't do anything anymore. What else? Facial hair for human beings is completely basic at this point, neutral. So it does have a purpose in some places, but most people just shave it off. Well, what's its original purpose?
Insulation.
It was insulation. That's exactly right. It was insulation. So maybe you can think of it to that degree now, but I don't think most people do. What else?
Eye color.
Eye color. Who cares? Right? That's exactly right. It doesn't make a difference. In some cases it can, because blue eyes are much more sensitive to what? They're much more sensitive to light. So if you have blue eye color and you're down at the equator, it can be pretty bad news. And so typically you see less of that. And if you have dark hair color, dark eye color, it really doesn't have any disadvantage at the northern bound, but it does the other way around. So maybe a little bit adaptive on that case. I wouldn't say completely neutral at all. But what is? Hair color is. Right? That's not a big deal anymore. What else? Here's some simple ones. How many of you guys, well, now that's actually something that we'll think about. What about nipples on men? Why? Right? They don't really have any benefit whatsoever, but there they are. Freckles, neutral. Attached earlobes, detached earlobes, neutral. Okay, there's tons of these kinds of neutral traits in the human population. So they don't convey any advantage or disadvantage, so what do? Leave them alone. They have a tendency to accumulate over time. That's actually a great thing. Why do you think it is that we accumulate neutral traits? Why do you think that might be a great thing? What's that? If the environment changes, they might become what? Useful and adaptive. Or they might become maladaptive. It just depends on the change in the environment. So that's just some examples among human beings, all right? You've seen these terms before from 1A, so I'm not going to spend a lot of time on them. I just want to do a brief review. So we're interested in this idea of where variation comes from, right? Information of heritable traits, and it occurs in the genes. Well, what's a gene? A unit of heritable information in the DNA that codes for specific traits. So if I was to say eye color, that's a gene. Hair color, that's a gene. However, if I was to say brown hair, that's a what? That's an allele, okay? That's an alternative molecular form of the gene. If I was to say blue eyes, that's what? That's an allele. That is a different molecular form of the gene. So again, the gene is basically the hereditary unit, and then the allele is the different forms of it, okay? And alleles can be dominant, recessive, incomplete.